Welcome to Physics 310. In this section we are going to learn about unit vectors. Suppose we have x, y and z axis in 3 dimensions. This is your x, this is your y, and this you can say it is your z. So I cap is unit vector along x-axis. J cap is unit vector along y-axis, and k cap is unit vector along z-axis. So why they are called unit vector? Because their magnitude is 1. So I cap is this way, and magnitude of I cap is 1. It's a unit vector, a vector having magnitude 1 in the direction of x-axis is unit vector I cap. So its magnitude is 1, but this vector points along x direction. J cap is unit vector along y-axis, so magnitude of J cap is 1. K cap is unit vector along z-axis, so magnitude of k cap is equal to 1. So I, j, k are unit vectors along x-axis, y-axis and z-axis. All these vectors have magnitude. In your books you may find I cap is written as I with bold letters. Just I, not I cap. J cap is written with J, bold letters, J. K cap is written as K, bold letters. So please do not confuse, both are same things. Now let us see what are the advantages of using unit vectors. Suppose given displacement vector S is 50 meter along plus x-axis. Okay, so this is magnitude, this is direction. One can simply write S, displacement S is 50 meter I cap. So this I cap means unit vector along plus x-axis. So its magnitude is 1, so it is not affecting the magnitude of your original vector. But when it adds with the original vector, when it adds with the magnitude of original vector, it represents the direction. So I cap means this vector is working along x-axis. and it has a magnitude 50 meters. Let us take another example. Suppose you have a vector F is 5 Newton this way, and its components are 4 Newton this way and 3 Newton this way. So you can find out this looks like a right angle triangle. So square root of 3 Newton square plus 4 Newton square is equal to 9 Newton square plus 16 Newton square. Square root of 25 Newton square is 5 Newton. So that's how it becomes 5 Newton. So you can think that this is your x-axis and this is your y-axis. So you can write vector F has a 4 Newton component along x-axis. So you can write 4n I cap, means this 4 Newton is along x-axis, plus it has a 3 Newton component along y-axis, so 3 Newton j cap. Or simply you can write F is equal to 4I plus 3j Newton. So you can express vector in its components, and magnitude of F you can calculate, it is going to be 5 Newton. That's the vector it is. So you can express the component of vectors in terms of unit vectors. They simply tell that this component is along x-axis, this component is along y-axis. So once again, K, I cap, J cap, K cap are unit vectors along x-axis, y-axis and j. Now earlier I discussed addition of vectors. So how about subtraction of vectors? How can we do this? If you have vector A and you have vector B, then you know that A plus B is going to be this vector. This is vector R is equal to vector A plus vector B. Now if I need to find A vector A minus vector B, what I need to do? How to find vector A minus vector B. Okay, so one can write, suppose vector A minus vector B is R prime, so we can write new vector R prime is vector A minus vector B. We need to find this. What it means that this can be written as vector A plus vector minus B. Okay, now we know that this is vector A, exactly. We know this is vector A, exactly same direction, same way. Plus I have to add vector minus B. This is vector B, this way. So what would be vector minus B? Minus B will be exactly opposite to this. So if this is B, the minus B is going to be exactly opposite this way. So minus b is going to be exactly opposite. Minus b, and then you have new resultant r prime vector a minus vector b. Okay, so this is how you do subtraction of vectors. Component method, or you can say analytical method to find resultant of many vectors. Yes. Component method or analytical method to find resultant of many vectors. So suppose I have several vectors. Suppose one is this a1, another is this a2, and another is this a3. Okay, and there could be many more, a4, a5 with random directions. So we are going to use component method to find resultant of all these vectors. Alright, suppose they make angle theta 1 here, theta 2 here, theta 2 here, and theta 3 here. A1 is making angle theta 1 from horizontal, A2 is making angle theta 2 from horizontal, A3 is making angle theta 3 from horizontal. So how to find the resultant? It is a three-step process. Step 1, find x components of all vectors and add them together. Add them together. Add them together. Okay. So what will be the x component of A1? If you project it on x-axis, from here to here, this is going to be x component. A1 cosine theta 1. The x component of A2 is going to be A2 cosine theta 2. X component of A3 is going to be A3 cosine theta 3. So now they all are along horizontal direction, so they can be added. Okay, they all work in one plane, one horizontal direction, so they can be added without any problem. So what is the sum of all? That is called AX. Suppose we call AX is going to be, we can say it AX or RX, any name we can give. AX is going to be A1 cosine theta 1 plus A2 cosine theta 2 plus A3 cosine theta 3. And if you have many more, you can keep adding A4 cosine theta 4 if there is A4 vector, and so on. Okay, this is going to be this vector. The sum of all vectors works in horizontal directions, and you can add unit vector I cap. I cap means this sum is working along x-axis, or AX is working along x-axis. So you have got a sum of all these vectors, and this is the sum AX. Okay, it is working along x-axis. Step 2. Find y components of all vectors and add them together. So what would be the y components? This is going to be your y-axis, this is your x, and this is your y. So if you project this vector along y-axis, from here to here, this is going to be AY of this vector. From here to here, this is going to be A1 sine theta 1. Very similar. This is x, so the y is going to be this way, and if you project along y, this is going to be A2 sine theta 2. If you project A3 along y-axis, this is going to be A3 sine theta 3. So find y components of all vectors and add them together. So suppose the sum of y components is ay. One can also write ry, whatever symbol one you like, you can use it. They are working in vertical plane, so they can be added simply. A1 sine theta 1 plus A2 sine theta 2 plus A3 sine theta 3 plus, if you have many more, you can keep adding. And this whole sum works along y-axis, so I can write j cap. J cap is the unit vector along y-axis. So what you did, you have simplified all these complicated vectors into two simple vectors. One is ax and other is ay. Ax working along x-axis, and sum of all y components, that is ay, vector ay, that is working in y-axis. Ax is sum of all x components, ay is sum of all y components. Then step 3. Find the magnitude of resultant vector and its direction. Find the magnitude of resultant vectors and also find its direction. How can we do this? What will be the resultant of these two vectors? The resultant is going to be this vector r, this is going to be resultant r. So you can write vector r, it has x component ax, so ax I cap, okay, magnitude of ax is ax, magnitude of ay is ay. So axi, so this vector r has an x component ax, so it is axi plus ay j. How about the magnitude? Its magnitude is going to be a square root of ax square plus magnitude of ax vector and magnitude of ay plus magnitude of vector ay whole square root. How about its angle? Suppose this angle is phi. Can we find the angle? Tan of phi will be equal to ay over, tan of phi is going to be ay over ax. So phi will be how much? Tan inverse ay over Ax. That's how you use the analytical method or component method to find the resultant of several vectors and the angle of the result.